Hello there. This video lecture covers threads and concurrency. Okay, so this topic is next to processes. Okay, so the last video that we had. All right, so let's get started. So bear with me, this discussion is a little bit too technical. Okay, and we will be dealing with a lot of terms here. Okay, so for the outline of the video, so we will be dealing with an overview of a thread. Okay, so also included are the multi-core programming, the multi-threading models, the thread libraries, implicit threading, the threading issues, and some operating system examples when it comes to threads. Okay, so at the end of this discussion, so we should be able to identify the basic components of a thread and contrast threads and processes. So last time we talked about process, and when you say process, this is a program in execution. Okay, so how about threads? So threads before, okay, during the process discussion, we defined it as a sub-process. All right. Next would be describe the benefits and challenges of designing a multi-threaded applications. Illustrate different approaches to implicit threading, including thread pools, fork join, and Grand Central dispatch. So describe how Windows and Linux operating systems represent threads, and design a multi-threaded application using the pthreads, Java, and the Windows threading APIs. So let's start with the definition of thread. So what is a thread? Okay, so thread basically is a basic unit of CPU utilization, consisting of a program counter, a stack, and a set of registers, and a thread ID. Okay, so what are the motivations for having a thread? Okay, so most modern applications are multi-threaded. Okay, so threads run within application. So that means thread is a sub-process. Okay, so multiple tasks with the application can be implemented by separate threads. So update display, fetch data, spell checking. So our example is of course in Microsoft Word. Okay, so when we run the application, we have a lot of threads. Okay, so that was initialized when we open it. Okay, and then answer a network request is also a good example. Okay, so process creation is a heavyweight while thread creation is a lightweight. So that's why we have the motivation for creating a thread. Okay, so it can simply simplify the code and increase efficiency. Kernels are generally multi-threaded. Okay, so basically threads are very useful in modern programming. So whenever a process has multiple tasks to perform independently of the others. Okay, so a good multi-threaded application for programming is of course Java. Okay, so this is particularly true when one of the tasks may block and it is desired to allow the other tasks to proceed without blocking. So for example, so in a word processor, a background thread may check spelling and grammar, while a foreground thread processes user inputs like keystrokes. Okay, so while yet a third thread loads images from the hard drive, and a fourth does periodic automatic backups of the file being edited. Okay, so let me open here a task manager so that we'll be able to see the threads there. Okay, all right, So we have here our task manager. Okay. So of course we have here the processes running. Okay. And basically you'll have the background processes and some foreground processes running here. Okay. Or the Windows processes. Now, so these are the resources allocated to each of the process. Okay. Now looking at the performance, so let's examine the CPU utilization here. So the CPU utilization is 36%. So I'm using 2.7, okay, plus gigahertz of the CPU frequency here. Okay. Now, if you will observe here, with a 38% utilization, okay, and the speed of 2.74, though the CPU is basically 2.3 gigahertz, so you'll have that it exceeded the frequency. Okay. Now what I want you to pay attention here is the number of processes here. Okay. Now for the number of processes, so currently we are running 155 processes, and there are about 1683 threads. Okay. So if you are running virtual machines like VirtualBox, so you would also see here if you have enabled the virtualization on the CMOS. All right. Now, so currently I'm running 153 processes, and with that processes there are about 1,600 plus threads. Okay, so let me open MS Word here. Okay, so WinWord. Let me open it, and what I want you to pay attention with is the number of threads there. Okay, so examine or observe what will happen when I open MS Word. All right, so there is a sudden increase of the number of threads. Okay, so we just open Microsoft Word there. All right, and Microsoft Word has a lot of threads associated with it. So as mentioned earlier, so this includes like spelling check, okay, grammar check, what else, the keystrokes, the number of characters, and so on. Okay, so let me close this. All right, so next. Okay, so we have what we call a single-threaded or a multi-threaded processes. So traditionally, we've got the heavyweight processes. It has a single thread of control. So there is one program counter and a sequence or one sequence of instruction that can carry it out at any given time. Okay, now as shown in this diagram here, okay, so we've got a multi-threaded applications, okay, and it has multiple threads with a single process. Okay, so you've got multiple threads here. Okay, so this string like diagram or symbol here represents a thread. Okay, now we have here a multi-threaded process. If you will observe, we have 3 threads running with a single process, and each of the thread has their own registers, stack, and program counter, but the code, the data, and the files are shared among the threads. All right, so next would be the multi-threaded server architecture. Okay, so what do we have in the multi-threaded architecture? So another example of a thread, okay, so like what we mentioned earlier, the MS Word example. So another example is the web server. So multiple threads allow for multiple requests to be satisfied simultaneously, okay, without having to service requests sequentially or to fork separate processes for every incoming request. Okay, so a daemon would listen at a fork of a child for every incoming requests to process, and then go back to the listening port. All right, so that is shown on this diagram here. Okay, so next would be what are the benefits of a thread. Okay, so basically there are 4 major categories of benefits to multi-threading. So these are responsiveness, resource sharing, economy, and scalability. Okay, now on the responsiveness, so one thread may provide rapid response while other threads are blocked or slowed down doing intensive calculations. All right. So next would be resource sharing. So by default, threads share common code data and other resources as shown in the model earlier. Okay. So which allows multiple tasks to be performed simultaneously in a single address space. That's resource sharing. Okay. Third is economy. So creating and managing threads and context switches between them is much faster than performing same tasks for processes. All right, so that's economy. And the last one would be scalability. So an example of this is the utilization of a multiprocessor architectures. Okay, so a single threaded process can only run on one CPU, no matter how many may be available, whereas the execution of a multi-threaded application may be split amongst available processors. Okay, so note that a single threaded process can still benefit from a multi-processor architectures when there are multiple processes contending for the CPU. Example, when the load average is above some certain threshold. Okay, so basically the use of threads are beneficial. All right.